did that function part in Python. Okay, now today we will continue the next part of function, that is, you can say, recursion, Python recursion with Python function. Okay, now tell me, do you know the concept of recursion? What is basically a recursion? Maybe in C and Java classes we have already discussed about recursion. Uh, what is basically a recursion? See, repetition is a process, okay, in programming. Repetition, what is that? Repetition, okay, repetition. Now this repetition can be done in programming in two ways. One is your common to all, you know, that iteration. What is iteration? Iteration means looping. Looping, those all loops, while loop, for loop, do while loop. In other programming languages you will find do while loop, not in Python. But looping is iteration, and that is a repetitive process. Means if you need any repetitive process in your program, then you can use this technique. Loop means iteration, and the other one is your recursion. Recursion, okay. Now what is the recursion? Recursion, how can you implement that recursion? Iteration, you implement iteration using loops. Now recursion you will use function call. Okay, so recursion is basically a repetitive process done by calling functions. Okay, functions called in such a way that it forms a repetitive structure. Okay, now what happens when a function is called? A function is a separate body. Okay, a function is a body, something like that, an area. Okay, now when you call a function, this area is formed. Suppose f is a function, you call that function. When you call that function, this area is reserved, or this area is allocated from memory. Okay, and whatever means you can imagine like that, that when this function is called, certain area from memory is reserved. Okay, or the control is transferred. Rather, you think in that way, when a function is called, the control is transferred to a certain area in memory. Okay, and it starts executing the codes over there. Okay, now see, if the thing is like that, a function is called, the control jumps to that area. Now what happens if you call the same function somewhere inside this area? Now what will happen? You can think this will happen like that. The same type of code or a block will again be allocated. Okay, and the control jumps over there. Maybe you can think like that. Okay, this way you can understand the recursion easily. Okay, so the control jumps over there and again do the do all those tasks over there, and eventually it will find that function here also, that call. Again what it will do, it will do the same process. Now don't you find a repetitive structure here? Sure, if we are inside a repetitive structure, means this task is repetitively done here. Okay, this is recursion. Means a repetitive structure you formed with a function call. Okay, Now, what happen if this will go on and when to stop, that we will discuss later inside the discussion. Okay, but initially you think, what is a recursion? Recursion is a repetitive process which is implemented by use of function call. Okay, got it? Just one or two reply.
Yes, sir.
Okay, fine.
Yes, sir.
See, this is the concept of recursion. Whatever I said here, you can find it still. Just quickly read this thing out. Recursion is a repetitive process with the help of function call. Okay, fine. Next type of recursion. There are two types of recursion. You can say direct recursion and indirect recursion. Now, what is a direct recursion and what is an indirect recursion? Now, if I tell you that function call, using function call, we are actually implementing the concept of recursion. So, recursion can be classified into two different approaches. One is your direct, and another is your indirect. Indirect. Now, what is a direct recursion, direct recursion, and what is an indirect recursion? Okay, direct recursion is basically when a function calls itself. Means, see, this is a function f, and inside that function you are again calling f. So what happens? This function calls itself. This type of recursion is called direct recursion. Okay, when a function calls itself, that type of recursion is called direct recursion. Now, what is an indirect recursion? Suppose f is a function. Inside that f, you are calling another function h. Okay, now which in turn call f again. Then what will happen? When this function is called, coming inside this function, h will be called, and when you are inside h function, you are again calling that f function, and this way repetition will be performed. Okay, now this level means f to h, h to I, this may go up to n level, no problem. But since the same function is not calling itself, some other function is calling the previous function, it is something like that. Okay, means A is calling B, B is calling C, C is calling D. In that way, the last one is again calling the first one. This is a circular process. Okay. So if the recursion is performed in that way, is designed in that way, that time that recursion is called as indirect recursion. So what is a direct recursion? A direct recursion when a function calls itself. Indirect recursion. What is indirect recursion? In indirect recursion, a function calls another function, which in turn call the first function. So that is an indirect recursion. Now, when you need direct recursion, when you need indirect recursion, that depends on the programming situation. Okay, that you have to decide during the program. uh, so let's move to the next point. So type of recursion you understand, I hope. Next is your recursion has a function call overhead. Okay, now this thing you have to understand that whenever a function is called, there is an overhead. Now, what do you understand by overhead? Overhead means uh, means a time consuming factor, or a headache, you can say, or a pressure which is extra, as a burden. Okay, now function call comes always with a burden. Now, what kind of burden it is? Now, what is a function call? Function call means when a function is called, suppose this is your program, main program, you can say, main program. So inside that main program, instructions or commands are executed sequentially, line by line, or in some any fashion. So if you have some function call, then it need to jump to some other place in memory. Okay, means while you are executing inside that function, you have to move out of that function and go inside some other function, some other area. So this is called jumping. Okay, now whenever a jump takes place, what happen? It takes time. Okay, now when you are jumping to that place, now at the end of this function, you again have to return to that previous place. That is also a jumping. Okay, so two jumps required when a function calls appear in your program. Two jumps. First, you move into that called function, then you are coming back to the main function. So whenever a jump take place, okay, it will take some time, extra time. Okay, now this extra time is you can refer as overhead. Just imagine uh, today is Christmas. Okay, you want to have some food. Okay, maybe some party or something. That what you can do, you can in this time of evening, you can move out to a shop, near shop, or somewhere, a shop, a restaurant, and buy some foods for you and bring it back, and then have those foods with your family. Okay, now nowadays you can do some other thing. You can call the food delivery. Means you can always put an order in food delivery apps. Okay, like you know, some are called Zomato, and those all. Okay, so what is the advantage of calling that food delivery apps? Means what is the advantage of calling or giving your order to Zomato? That you do not have to travel to that restaurant or the shop. Okay, so the time that you should have expense buying the food, you are not expensing that time. Maybe you use that time with your family members for some other work. Okay, so you do not have to jump to that place. Okay, if you have to jump to that place, that gives you an overhead. Okay, so you have to adjust your time when to go to that shop. Okay, bring the foods to your home, like that. You understand the fact? So here also, whenever a function call take place in the program, a jump, okay, is encountered. Now whenever a jump is there, some amount of time, extra time, is added to the program execution. That is called a function call overhead. Since recursion is fully based on function call, so this point is there. Recursion has a function call overhead. That means you should not use the concept of recursion without proper analysis, that you need recursion. Recursion will benefit you. You do not use recursion just like that. Okay, let's use recursion. Do not use recursion in that way. That will make your program slower. Okay, the time complexity of your program will increase if you unwisely use the concept of recursion. Okay, so it increases time complexity, hence need a concern. Means you, if you want to use the recursion, you must concern all those things, whether you really need that recursion or not. Okay, okay, now one thing you can say, why you need recursion: it reduces the code complexity. And loc means lines of code. Okay, so why you use recursion? Say, sometimes using a recursion, a long code may be reduced to a few lines, means maybe reduced to a code of few lines. Okay, so that is a great advantage of having recursion. It makes programs less complex, or maybe a simple one, looks like simple one. For example, if you remember from your data structure classes, okay, the code of towers of Hanoi. So if you want to write that code without recursion, then it will be a very big program. But with the help of a recursive approach, the code will reduce to just only a few lines. Okay, so that is the concept where you use recursion, that you have to think. It is implemented using stack data structure. Now, this this concept you also have to understand from the side of data structure. Now, whenever a function is called, that function call is stored inside a stack. Okay. Suppose f function is called, f is a recursive function. So first time f is called. Okay. So this stack will contain this way. First time f is called. Now coming inside the f, this f is called second time. Okay. Then what will happen? Another function call will be pushed inside the stack. Means involvement of stack is not for only recursion. Whenever a function is called, system always keep track of what are the functions that have been called in order inside a stack. Okay, means suppose there is a function f. Inside a function you are calling another function g. Inside that function you are calling another function h. If something like that, then system will store all these function calls in the way in this way, f g h. Now you remember that the function that was called last must be returned first. Okay, that means the last function that was inserted in the stack will be deleted first. What type of data structure is suitable in this case? In that case, that is stack. That's why system use stack to maintain function calls. Okay, since recursion is based on function call, so obviously system implement this concept using stack data structure. Okay, okay, maybe we will discuss this thing later also. Now, what is a direct recursion? I have already described this. What is a direct recursion? See here, this is a direct recursion function. How to identify whether this function is a recursive function? You find that this is a function call. No? The same function call you are calling inside the function body. Okay, so here, from here, this function will be called next time. Okay, so whenever you find the same function call inside the function, that time you can identify that this function is a recursive function. Okay, now one thing you mm, must know, or you must take care, that see, this is the, let me change the color a bit. Look at this condition. This is a very important condition. Okay, this recursive function call is coming under this condition. This recursive function call is coming under this condition. Okay, the importance of this condition is immense in recursion. Why? See here, what is happening here? So you are calling the recursive function call. Mean this is a recursive function call. The function call from where the recursion is take place, we can call it as a, we can call this line as a recursive function call. From here, the function will again be started. Okay, so this must come under a condition. Okay, that condition, you can identify that condition as a base condition of recursion. You can call it as a base condition of recursion. Now, what is the importance of this base condition? See, whenever we are calling that, whenever we are applying that recursive function call, when we are calling this recursion, means this function call, if the condition satisfy, so if this condition is true, then we are going for recursion. means we are calling the same function again. If this condition is not true, then we are returning. So see here, if there is a function, okay, and you are calling that function without any checking, then what will happen? It will call infinitely itself. It will call infinitely itself. And as I have already said that for each function call, some amount of memory space will be occupied from our RAM. So if this function calls itself repeatedly infinitely, then infinitely some amount of memory will be allocated. Now our RAM is not infinite, na? RAM is finite. It has a certain amount of maximum size that can be allocated. So after a few time, what will happen? All the amount of memory space will be allocated to this single function call. That time system will not run, maybe hang. So this kind of situation is protected. Okay. So you should take care of that condition. Okay. So this recursive function call must come under a condition. That condition is termed as base condition. It is there to make a provision to break the recursion. That recursion loop, somewhere you have to break it down. Okay. Otherwise it will put an effect just like an infinite loop. You have many infinite loop experienced many infinite loop during your learning. Okay. So this base condition is breaking that loop. Okay. So you must have that break condition for recursive function call. Okay. So what is next? Next is your indirect recursion. Okay, before going to indirect recursion, I would like to demonstrate a few. But before that, tell me, do you understand till now? Do you have any problem or anything to ask? Tell me quickly.
No, sir, no problem. No, sir, no problem.
Okay, then look for a demonstration. So today we will use say VS Code. Quickly add this folder to the VS Code. Demo or recursion one dot. Okay. So this is our program. What we will do here, we will create a function. Say def say we will create a function which will just print some data, not writing any complex function first. Say I am giving the name print, and inside that I am passing the value. Okay. So we will use this recursive function to print some numbers, maybe say 1 2 3. Okay. So it will print the numbers from 1 to 3. Okay. So how to write a recursive function for that? So I'm defining that print function. Okay. I'm giving the name is different my print, because print already you have a function, system function called print. Okay. So I'm giving my print. Okay. So inside that my print, I am just printing the value n and just put a comma after that. After that, I'm incrementing the value of n by 1 and I'm checking if n is less than equal to 3. Okay, then I will call the myPrint function with the current value of n, else we can say return. That's all. This is our writing our main function and just call myPrint inside O plus 1. What it will do, run it first. Save the program and run it. See here, 1, 2, 3. Three numbers have been printed. Now, usually, if you do not use recursion, then you can do that thing using a loop. Okay. In Python, you can use that range to print the numbers also. But normally, using a loop, you can do that thing, that repetitive, using that repetitive concept. Now, if you want to print the values from 1 to 10, then you have to make it 10, save it, run it. See here, 1, 2, 3, 4, up to 10. Okay. So we are printing this number in a recursive process. How this process is actually happening, that I will show you. See here, I'm just copying the code and maybe go into paint here. Initially, what I am doing, I am just calling this function. Okay, I am just calling this function myPrint. So what is our myPrint? I am just boxing out this function. Okay, visually you have to understand. See, if you call this myPrint1, then sorry, I can say that this new section is been introduced. Okay, so when you are calling this function, I am saying that the control jumps into this function with this value 1 is passed inside this n 1. Now tell me, execute this function using the value 1 in n. You understand, na? This myPrint function is called. That's why I am writing this box. Okay, and the control is jumps inside this function. Okay, initially the control was there. This is the main function. Okay, this is the main function, and you cannot write initially when the function start. The control is now here, myPrint. Now, since myPrint is a function call, so it jumps into that area. Okay, while it is coming inside this function, it stores the value 1 inside this n. So you have to now execute these lines with the value n equal to 1. Tell me what will happen. First you have, okay, I am creating a section output. Okay, so first you have print n. So what is the value of n here? Tell me, reply quickly. n is your 1. Okay, so 1 will be printed and a comma, this comma. Okay, after that this statement will be executed. So what will be the value of n? N plus equal to 1, n will be your 2. Okay, now coming to the if part. So 2 is less than equal to 3. Is the condition true? Yes, it is true. Then you are moving inside this if part. Okay, so what is there inside if part? You have that function call again, my print n. Now here this n is 2. You have to note that. Okay, now what will happen? Since it is a function call, so you have to write that code again. Another jump. Now while it is jumping, it is storing the value of n as 2 in this part, in this section. Okay, now the control jumps inside this function and these will be executed one after another. So here again you have print n. So what will be the value of n here? That is 2. Okay, so 2 will be printed along with that comma. Next, n will be updated. What will be the value of n here? N will be your 3. Now here in if part, 3 is less than equal to 3. Again the condition is true, so it will come inside this loop. So here now n is your 3. So again there is a function call. So you have to jump to another function, another area, the same function. Now for this function the value of n is 3. So coming inside this function, print n. So what will be the value of n here? 3. 3 will be printed. After updating the value of n, so n will be your 4. Now see what will happen here. This condition will become false, right? So this line will not be executed. So else part will be executed for the first time. Now what is there inside else? It is return. So where it will go? It will return back to that place where it was, from where it was been called. Okay, so here in this part, inside, after this line, after this my print function call. Okay, now since now you are not inside this function, you are not inside this function, you have already returned here. Okay, now from here your control will going out of this function. That means it is implicit return, you are returning back to the previous function. That means this second function call has all means has also returned. Now here now you are here. Okay, again the same thing will happen. You are going out of this function, that means you are implicitly returning. So from where you were started, you have reached to that place, and in the meantime, see, your purpose has been solved. 1 2 3 has been printed. So this is the way how this function call takes place in recursion. Okay, now if you consider stack, see here, if I design a stack for the whole program, so what is the first function that was been called for this program? That is this my print function. So my print function will be there first, my print one. After that, which function is called? See here, inside my print function. Okay, one. Inside my print function, you have another function call that is also my print. My print. What is the value? 2. Okay. So you are coming here. So inside that function, you have again another myprint function call. So it is your myprint 3. Now see, when you are here inside this function, you are not calling this function anymore. So you do not have any other function to push into this stack. Okay, so if you remember stack is your LIFO, last in first out. So which function is been inserted in the stack last? That is this this function, means this function, this third one. So it will be returned first. Okay, then this will be returned. See, this is returning. Then this function will be returned, means this is returning. Hence the stack is empty. Now when the stack is empty for the program will terminate. Okay, so this is the way how recursion takes place in programming. And for that recursion we have to write the code. Now this is a direct recursive function call. Okay, means my print is calling itself. So you can use the term direct recursion with this program, with this function. Quick reply if it is gettable to you.
Yes, sir.
uh, some suitable programs, means common programs in academic area, where recursion can be used very frequently, like finding factorials. Okay, finding Fibonacci number or series, GCD. Okay, finding GCD. These kind of programs we usually face in any course, programming related course initially. Okay, anyway, you will find recursion in data structure, where a tree is concerned, binary search. Okay, so recursion is there. Okay, okay, fine. So this was your direct recursion, one simple function call, simple recursive function. Now we are moving inside the indirect recursion part. Okay, so next is your indirect recursion. Now what is indirect recursion? Indirect recursion, as I told you, see here, the fun is, this is your fun one, and inside fun one you are calling fun 2. Okay, now inside fun 2 you are calling back the fun one. So here the same function is not calling itself, another function is calling the first function. That's why it is called indirect function call. Okay, now from where the repetition start, this is the function call from where the recursion is take place. So we can identify this function call as recursive function call. Okay, so this is a recursive function call, and a recursive function call must come under a condition that you can term as base condition of the recursion. Mm, okay, okay, okay. These all points have been discussed already. Okay, okay. Now another variety of recursion, means a classification, a different uh, way of classifying recursion technique. One is your head recursion, another is your tail recursion. Now when the recursive function you identify in the earlier discussion, we have identified what is called a recursive function call, na? Recursive function call. Okay, so now now when the recursive function call inside a recursive function, this is a recursive function. Now when this recursive function call appears at the very first, means all other part of the program is coming after that recursive function call, then that type of recursion is called head recursion. Head means the recursive function call is coming at the header part, or at the very first part, very first line of the function is the recursive function call. And what is a tail recursion? The recursive function call coming as the last statement of the function, means all other function have been executed before the recursion takes place. Okay. Now, what are the difference? How these two things are differ from each other? See here, when you have a head recursion, okay, that means what will happen? So whenever the function is coming inside this body, okay, it is moving to the next function call. Okay, keeping this whole body mm, undone for that particular function call. Okay, now if you consider this one, when this recursion is take place after completion of the whole body. Okay, now if you have something like that, means this recursive function call always will come under a condition. Okay, means if your task is like that, you want to perform this task only when certain condition is satisfying, otherwise you have to skip that function call, then you can do that thing. Now one thing I can also tell here, see recursion, you can compare recursion just like this staircase. Okay, when you are calling first time the function, here you are. When you are calling the second time, here you are. Third time, fourth time, like that. Okay, fifth time. Okay, maybe you are stopping here. Okay, now if it is a staircase, then you have two things, while you are coming down and while you are moving back. Okay, now if you design a head recursion in that way, if you design the recursion in this way, that means if it is a head recursion, then what is happening? See here, as soon as you enter inside the function, you are moving to the next function. That means this task you are not doing while you are coming in downward direction. You are doing this work here while you are moving or while you are returning back. Okay, now if you think for this one, so the same thing, f1, say f2, f3, f4 and f5. This f1, f2, f3, f4, f5, these are all the instances of the same function. Means for the first time when you are calling the function, that is f1. The next time, the second time when you are calling the same function, I am assigning it, I am telling it as f2. Okay, don't think that f1, f2, f3, these are all different function. No, not like that. These are the different instances of the same function. So here the same thing, in this staircase you can go downward. When you are calling the recursive functions, you are going downward from f1 to f2 to f2, f3, f4, f5. When you are returning, you are going in the reverse direction from f5 to f4 to f3, 2 and 1. Okay, now here this block of code is executing as soon as you enter inside the function. This block of code is executing, after that you are moving to the next function, right? So this block of code is executed while you are going down, moving down. So this is the difference between these two, head recursion and tail recursion. If you have that kind of requirement in your program, that all the body need to be executed while we will return in the recursion, while we will return in the recursion tree, then you will do that head recursion. If your task is like that, you have to perform all the tasks before the recursion take place, recursive function call take place, then you have to proceed for tail recursion. Okay, if your recursive function call is anywhere between these lines, okay, then it is not neither a head recursion nor a tail recursion. Okay, so everything depends on you, how you design your program. According to the requirement of the program, you will design head recursion, tail recursion, or normal recursion. Okay, so these are the common programs in recursion. You can try these programs at your home. Okay, now I am giving you a demonstration of uh, indirect recursion, then we will move to the next part. See, recursion 2.py. Say I'm writing a function def, say fun. I'm just developing the function in front of you, indirect recursion. Uh, just a demo function, nothing else. Say I'm here printing I am fun. Dot dot dot. After that, I am fun. Start. Then I am calling a function gun. Then I am writing another statement. I am fun. Dot dot dot. End. Now what will happen? See here carefully. When this function is executed, first this line will be printed I am fun start. After that gun will be called. Means from here the recursion will means the control will jump to some other function. This line will be withheld. It will not be executed. When it will be executed? It will be executed when the control back from this function. Okay. Now let me write the other function, that is your def gun. Means I can copy that function. I have to just change the names of the function. Gun. Say I am gun. Gun. Gun is saying same thing. Here I am calling the fun function. Okay. Now see what will happen. Def is means this fun when what I will, this is my main. Here I will call this fun. Okay, fine. Now when I am calling this fun, so initially this line will be executed. This function will be called. This inside this function, this line will be executed. Right? I am fun. Start. Okay, fine. Inside after that, this gun will be called. Now when this gun is called, control jumps inside this gun. This statement will remain non-executing. Okay, means this statement will not be executed at that time. Okay, so the control jumps inside this gun function and this line will be executed. I am gun start. After that it will execute this fun. Okay, now when this fun is executed, when this fun is called, the control will again jump from here to this fun method. Again this line will not be executed that time. Okay, so what you got? I am fun start, then I am gun start. Then since now the control is here, then again I am fun start. After that gun is called, it will come here. I am gun start. So you will continuously get I am fun start, I am gun start, I am fun start, I am gun start like that. Okay, you understand? Now tell me how far or how many times this will execute. Hmm? You can always guess how many times this will be executed. This will execute for infinite time. Why? Because what is your What was your recursive function call here? This is your recursive function call. This is your recursive function call. And we have not put that recursive function call inside any condition. So it is open. So whenever the control comes here, it will go back to this function. And from this function, this gun will be initiated. So it will iterate for infinite times. Okay. So you can check it at your home. But currently, I have to put this function call inside a condition. Now, what condition I will give? I have to give a suitable condition so that after a few times, this iteration or this repetition breaks down. Okay. For that purpose, I can always pass a value, say maybe say 1. I'm passing the value 1. Otherwise, I will not be able to stop that recursion. Okay. So this is n. Maybe this is also n. Okay. So I am passing, when I am doing this thing, I am passing that n plus 1. So 1 will be, this gun will be called with the value 2. Now I am checking if n is less than equal to 5. Okay, that time I will call this fun. That time I will call this fun. When this value, means the value of n exceeds 5, I will not call fun. That time it will start returning. That time it will start returning from here. Okay, quickly run this program. See here, look at the output. I am gun. See, this is the start of the program. Okay, so I am fun, start. I am gun, start, fun, start, gun, start, fun, start, gun, start. Okay, at the end, fun, end, gun, end, like that. Okay, now I am just decreasing it a bit. 3, then run it again. Look at this. First, when the fun is called with the value 1, okay, you remember the code. You should remember that code. Okay. Okay. Now, when this fun is called with the value of 1, okay, first time this line will be printed. This line will be printed. Okay. That's why we get I am fun. Okay. After that, n is incremented, not incremented. After that, gun is called with the value of n plus 1. That means n plus 1 means 1 plus 1, 2. So gun is called with the value 2. Okay. So inside gun, what is there? Inside gun, you are printing that I am gun start. That's why you are getting this line. Okay. So after executing this line, inside this if, the value of n is checked. What is the value of n? The value of n now is 2. Okay, so 2 is less than 3. This is true. Okay. So fun is called with the value 2. When the fun is called with the value 2, here it's this program, this function starts again. So print I am fun. Again you are getting this one. Okay. After that, gun is again called with the value 2 plus 1, 3. Okay. Now when it is 2 plus 1, 3, come here. Now here n is your 3. So you are printing I am gun start. So this is printed. Okay. Here the value of n is 3. So 3 less than 3. Now fun is called with the value 3. So again go back to fun. Now here n is your 3. So print I am fun start. So you are getting I am fun start, right? This is matching. Here gun is called with the value 3 plus 1 4. So inside gun n is now 4 and I am gun start. So you are getting I am gun start, right? Now here 4 less than equal to 3 condition false. See here, first time the condition goes false. So this will not be executed. Where the control will go? It will go here. So first time it will print I am gun end. See here, I am gun end. After that what will happen? See here, here this gun is stop executing, returning back to where? Returning back to the previous call. Previous call means gun was called from this fun. So now control is here. I am fun end. I am fun end. Okay. Now since this function is returning, so it is returning where? The control is returned back to from where the fun was called. From here the fun was called. So it is the control is now here for the previous function call of gun. So you are getting I am gun end. In this way, this will be executed. Okay, so this is your recursion. You have to understand the recursion very well if you want to write, if you want to implement the recursion suitably. Okay, so this is your indirect recursion. Direct recursion and indirect recursion both works in the similar fashion. The difference is that here the functions are two. You can perform different tasks in two different functions. Okay. Anyway, so that was all about recursion. I took a bit of time since recursion is important to understand. That's why I'm giving this much of time. Okay, tell me if you are all clear. Just wait a bit.